Okay, second of several videos on physics formulas. This one's on motion in two dimensions, projectile motion. So we're going to look at two major cases. Case number one, where height initial is equal to height final. So it's like a football kicker kicking, and where the ball lands is going to be on the same height. We're going to use the range formula. And we can only use the range formula if y1 equals y2, or the height final equals height initial. So the range formula is equal to v initial squared times sine 2 theta over g. V is the entire velocity, not just the horizontal or vertical velocity. Maximum height is a one-dimensional problem. Vertical V initial only determines height max and the time in the air. Now, for all projectiles, it's super important to remember that the horizontal velocity is constant and the vertical velocity determines the height max and the time of flight. Okay, so remembering that our horizontal velocity is constant. So whatever the horizontal velocity is here is equal to the horizontal velocity the whole time the projectile's in the air. So constant, 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 steady, 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 because nothing's changing. Okay, so case number two is where height initial is not equal to height final. The maximum height is determined by the vertical component. Horizontal component then times the time will determine the distance from base of the building. So our horizontal V times T is the horizontal distance. Use of the conservation of energy formulas, when it makes sense, would say the velocity at the top, or the potential energy at the top is equal to the kinetic energy at the bottom. So if it's a vertical V initial, So how far from the base of the building will it land? Find the horizontal velocity multiplied by the time of flight. That's an easy peasy. So as you know, the horizontal velocity times the time of flight. Time of flight will be found from the vertical V, so is 1/2 gt squared plus v initial t plus height initial. If height final is 0, then you're going to apply the quadratic equation, solve for t. A is negative 4.9, b is the initial vertical velocity, c is the initial height, and v final at any time t, anywhere in that trajectory, is equal to gt plus v initial. Vertical v initial is v final vertical. Remember, g is negative, that's a directional thing, and the horizontal velocity is constant, so v times cosine theta is constant. Now add the vectors. So what they're saying here is the velocity at some time t, this velocity has to have a horizontal and a vertical component. So you find horizontal v from the original equation, or from the original circumstance. Then the velocity vertical can be found by using this equation, solve for v final, and then add the two vectors. Remember the Pythagorean theorem, a squared plus b squared equals c squared. So c is a squared plus square root of a squared plus b squared. All right, and then like for example, like an airplane coming along here, some velocity v, if the vertical v initial is 0, and they drop something out, then we'll look at that. That distance that it would follow would be correspond to that horizontal v constant. And then if we're going to find theta for any given triangle, so v cosine theta, and then v times sine theta, if this is v, then the inverse tangent, or the arctangent, of the opposite over adjacent is equal to theta. All right, there you go. Have fun.